manufacture the first models for EUAs, and we tested that out with one trader in California. So he was trading very actively using
Right.
our model. But yeah,
So
for us,
California has its own, see, the thing with carbon trading is that every market is a regulatory. See, there are two markets. There's a regulatory market and there's a voluntary market.
yeah,
And in regulatory market, California and an ETS in Europe, they're the two biggest one compliance markets. So you're trading in compliance markets, not in voluntary market.
yeah, correct.
Okay.
Compliance mostly, yeah.
Okay, cool. All right. So I have some slides on that. When Pallav told me, so I had to. this is not my area, so I had to do a little bit of read up on this so that the blockchain talk can be relevant to it. And so there's a WhatsApp group that has been created, and I've shared the presentation as well as the links that I'm going to use. And and whenever you are, we can start it. And if you have any questions, just feel free to pause and we can have a discussion, and then and hopefully I'll give you an idea as to how blockchain works, as to how we see blockchain should work.
Yeah.
And then have some ideas on carbon credit trading, but generally, if you can get away with as to what the potential of blockchain is and you can understand the blockchain, I think this would be a good session.
Just one request, Rohit. Can
Yeah.
we record this session?
Please go ahead. Absolutely. Yeah.
Yeah.
I would love it. Yeah.
I think you can just go ahead.
I'll start.
Yeah.
Yes.
Okay. All right.
Yes.
So let's start. All right. So let me share the screen then. Okay. 1 second. Yeah. Okay. And just let me know if you can see my screen.
Yes.
Yes, loading up.
Okay.
Yeah.
All right. So let's start. Good morning, everybody. My name is Rohit Tripathy. I am founder of RanchiMall. RanchiMall was not supposed to be a blockchain company. It was supposed to be a mall on internet. And then we started looking at what are the things that we can sell on internet. And we realized by 2014, 2015, that we need to go the blockchain route because that's where the world was opening up. And since then, we have been doing things in blockchain. And the idea here is to give you some of our ideas, things that we have learned in blockchain. And also, I want to also close this by talking about some of the places where we think blockchain can be used in the carbon credit accounting universe. First the Kyoto Protocol, then the Paris Protocol, and now COP26, the Glasgow meet. The results of that. And so that's the agenda of the session. So the best way to start with a blockchain is actually to do a little bit of hands-on on blockchain. And that gives people a feel of the blockchain. So what we would do is that we'll create a blockchain ID, and you can see what exactly the blockchain ID is. And then we'll use one app that we have developed for ourselves, and we'll use that to send messages using that blockchain ID. So if you go to your WhatsApp group where we have shared some link, the first one, if you have a computer, you can try it on computer as well. You can go there, and it will open a screen like this. And this is a web wallet. And the idea about this web wallet is we wanted to make earlier when we started the blockchain space, everything was an app on Android, or everything was essentially a thick application that you had to install on your laptop. And that would download about 100 GB of data. Okay, for Flow, we had at that point of time, we had 10 GB of data. And before downloading the data, you could not do anything. So we knew that we had to simplify this. And so this is one of the results that came out of this. So if you go there and if you generate something like a Flow ID, you will get two pieces of data. One is the Flow address, and other is the private key. Now this private key is like a password. This is the most important data piece. Every asset on Bitcoin that you see today is linked to a private key like this. Anyone who has the knowledge of this private key will be able to transact on the Bitcoin blockchain, and he will also be able to transact on the other blockchain. And we are using a blockchain called the Flow blockchain, and so that's what you need. So this is your flow address, which will identify you in the public.
Okay.
And this part is your private key, which gives you right to move assets out of your public address. Okay. So flow address is something. Flow address, it is also termed as flow ID. This is the address. It's a blockchain address. It's a blockchain ID. This is an ID that you share. You can freely share with anyone. That's why it's a. You can see it as a public piece of data. And then you have a private key, and this private key no one should be able to see. All right. So right now my screen is visible, and obviously all of you are seeing that private key, and it's also being recorded. So I'm not going to use this private key, but for demonstration purposes, I'm going to show how this private key works. Okay. So now once you have this private key, the next question is what can you do with it? Okay. So what we'll do is we'll go to before we go there, if everyone can generate their flow addresses, and along with their name, and they can just copy it here. Okay, they press there to get copied. So if they copy it and share in the WhatsApp group, that everyone else will know each other's flow addresses, and then we can start sending messages to each other. Okay, so I'll give you 2 minutes time to do that. Go ahead, go to that link which I've shared in the WhatsApp. Go to this link, press generate flow ID, copy your address and private key somewhere else. Make sure that no one sees your private key, and then share your flow address into the group. And now, right now, this address has changed because I've regenerated again. So remember that it will only generate once. Okay, it's being generated locally. It will only be generated once. So copy everything and then only move away from the screen. Okay. So once you are done, then you can move forward.
Okay.
Okay. Okay. So now, if you have done that, let me look at how many people have done that. Just remember. Okay. So yes. So we have Rishi, Sanand, Pallaw. Okay, good. So I think that's if anyone else is there, they can do that as well. And now, so now I'm going to go to this link. Okay, this is the second link which I've given in the message. So if you look at the message that I've given you, the second message is the Flow Messenger. Now this is one of the apps. Okay, this is one of the blockchain apps. So this is like a messaging app, and where you can message from any Flow ID to any other Flow ID. And there were some couple of technological issues to do it without. It's totally decentralized. That means you don't to set the routing issue out here. So if you go here, you could click sign in and enter your private key.
Okay.
And you enter your private key, and then you try to send message to any of the people in the WhatsApp group and see if they can respond to you or not. Okay. So now in a normal email system, you need you have to first create an account. The account has to be verified, and after the verification, you can start sending email to each other. In this messaging system, you will be able to send messages to each other without any pre-registration. You can directly do it. And the reason why you can do it is because you can generate what is called as a digital signatures to your private key, and your digital signatures are equivalent to self-standing passwords. It's a password that gets generated every time for every single message, and it is there in the message itself.
Yeah.
Which is one of the benefit of the digital signatures. Okay, so that's what you got to do. You got to send each other messages. And I'll just go back again, and once again I'll show you how this works. So if we copy the private key again, and I will sign in. Okay, so this is a new account that I've created. So this is the first time I can send a message. So I can send messages and I can send emails here. So I'll use the chat. I'll go and do a new chat. Okay, and I'll add a contact. Now, for adding a contact, I need one of the people in the group. So let's go. All right. So I will use this one. I will use Sanand's flow address.
Okay.
Okay. And I will add a contact. So I'll just write this. Okay. It's not for, so okay, I have to add contact. So I have to add a contact and I'll enter flow address and I'll say Sanand. And I'll just say add. So the contact has been added. And now to Sanand. It has to store the message.
Yeah, again, once you again click the new chat.
Okay, new chat. Okay.
Yeah.
Okay. Yes, Sanand is there. That's right. Yeah. Cool. So now see, since I'm sending the message for the first time, the very first message will be unencrypted.
Okay.
Because I don't have what is called as the public. I have the flow address. The way Bitcoin was designed was your address is not exactly the public key, which is required to do encrypted communication. So there's another piece of information called the public key, and that public key will come once one message comes from the other side. So I'll say hello from Rohit to Sanand, and let's see if Sanand gets the message. Okay.
So you are essentially saying that only once the conversation starts happening,
Yes.
you will generate the key for that particular communication, and then you will start.
So the key is in the address itself. Okay.
Right.
Okay. So I got a message, hello back from Sanand. So yeah. So to answer that question, so the key is in the address itself. Okay. So a blockchain ID itself has all the keys. Okay. But I don't have that key. I only have the address. Okay. So I have to first send you so initially I send a message to Sanand. So Sanand now got my keys, my public keys. Okay. And after he responded me back, now even I got Sanand's public key. Yeah. Now every message that we're going to give to each other is totally encrypted, and on all of this message is being stored locally on your laptop. Okay, right. Or whichever machine that you're using it, because it's a decentralized system. There's no database out. Correct. What we have done is we have created. There's a certain problem with internet architecture, because when internet was conceived, it was conceived with the concept of IP addresses which were allocated by someone. So you need to have a fixed IP address to be able to reach anyone, and all the ISPs, they are not basically. ISPs only have a limited pool of addresses. So the actual IP address that you are getting is a temporary IP address, which the ISPs has given. Now, on those temporary IP address, it's not possible to. It's not a permanent address. It changes every single time. Okay. So because of which it's impossible to do direct one-to-one message, a peer-to-peer messages directly from any user unless the user himself has a permanent IP address. So to solve that problem, we had to create a decentralized infrastructure where we could locate the people on the both ends with their temporary ID so that they can send messages to each other. But we also have a version of the software on the Tor network, and in a Tor network you do get a permanent. You don't get a permanent IP address, but you do get a permanent identification on the network, and there you could do direct one-to-one. Okay, using the same IDs. Okay, all right. So this is how. So now. So this is how you see how a blockchain ID actually works. And you can. This is one of the apps, and you could say, so now the question is, so why do we need another messaging application when you already have, let's say, WhatsApp and Google Messenger, Facebook Messenger? The answer to that question is there are certain things you can do from the blockchain ID itself. You can create smart contracts. You can create what is called as multi-sigs on the Bitcoin blockchain. And all of those would need creation of joint cryptographic signatures. And those cryptographic signatures you cannot do from normal messaging systems because they have to be blockchain-enabled messaging systems. And since this is a blockchain-enabled messaging system, so once the economy grows and people start coming to the ecosystem, they would need a system like in which the only piece of information that is required to reach anyone is their private key, the public addresses, and nothing else. Okay, and so this is, and so now I'm going to show you another app. which is an idea that we have borrowed from this the web wallet that we have said. So we really found out that we can use these ideas in Bitcoin as well. So we created a Bitcoin web wallet. Okay. And here, if you now this is exactly same as the Flow web wallet where we did the whole thing. And so in this web wallet, if you if you generate your Bitcoin address, so now here you have your Bitcoin address here,
Okay.
and you have a Bitcoin private key.
Okay.
Okay, it's exactly the same way as the Flow work was done. And now if you here you can send messages to, so you can send Bitcoins to anyone.
Correct.
So you have to enter the sender and you have to enter the private key, and you check balance, you will get the balance, and you can simply enter the receiver address and you can give them an amount. Okay. Now the difference between our messaging application and a Bitcoin application is Bitcoin uses something called a blockchain, and we are using a decentralized application to hold the data. And in case of Bitcoin blockchain, the data is being held in its own blockchain called the Bitcoin blockchain, and we are going to talk further in this conversation. I'm going to show you how the Bitcoin blockchain works. Okay. So this is also a link which I've given you, and this I believe is one of the safest wallets here and the easiest wallets to get started. Okay, you just generate a Bitcoin address. You make sure that you're storing your private key. Okay, and when you have to send a message to send Bitcoin to someone, just you have to have first the sender Bitcoin address. You have to receive a Bitcoin address. The sender has to give his private key. If you have balance of Bitcoin, then you update the balance out here, and then the system will calculate the fees, and you just simply send. Okay, and this is the simplest wallet that you can get started, and also the most safest, because this software is not holding your private key. As soon as the private key is used, it is deleted automatically, and most of the other wallets, they actually hold your private key. Okay, and that makes it unsafe because they can be attacked.
So who's going to send me Bitcoin? Maybe everyone can send one Bitcoin each.
So anyone who has a Bitcoin today in the world, okay,
Yeah.
he has to send you some Bitcoin to get started. Okay, and so we have Bitcoin exchanges in the market. Like we have a lot of Bitcoin exchanges. So you put Indian rupee there, and then they will send you Bitcoin. And once you have the Bitcoin, then then you can then send to anyone. And Bitcoin is just like sending money. Like when you are sending money through UPI app, you are doing something like that. You're sending a information, and that information is transferring some of the balance that you had of Indian rupee into someone else's account. Okay, so it's a ledger. So UPI is essentially a ledger in which your UPI address is the holder of your rupee assets. And when you're doing a transfer, you're transferring a ledger balance from your UPI account, your UPI address, into someone else's UPI address. So it's the same concept here. Here you are sending Bitcoin from your Bitcoin sender address to a receiver sender address, and you just enter your private key, and then you get the balances out here. And of course, Bitcoin is an appreciating currency. So if you simply hold it for a couple of years, the value will go up. That's the most important application right now. But we think that Bitcoin can do much more important things. But it's still there's a lot of complications in technology, and once the technology gets sorted out, and that's one of the job that we are doing. We are actually simplifying the whole blockchain technology, and this Bitcoin web wallet is one of those examples. There's no one-click start Bitcoin web wallet anywhere in the world. We are the only ones who did that. Okay. All right. So that was the first handout I want to talk about. And any questions still now?
Okay.
All right. All right. Cool. All right. So all right. So we did this hands-on right now. Like we just created a blockchain ID and sent messages. All right. And I'm also so I showed you a blockchain wallet. And now what we need to know is to look at what is called as a blockchain explorer, as to how do you find out what any address is doing on the blockchain. All right. So what will for that there's some, so every blockchain has something called blockchain explorer, and in this case I'm using an address. So this is an address just like an address we just checked out here. Okay. So all you have to do, so there's a link again. The link, if you go okay, I think I've not given you this link, so let me give you that link. So it's called flowsite.dns.org.
Yeah.
This is something that this is a blockchain explorer for blockchain. Okay. And if you click, you'll get to the blockchain. So you get a screen like this, where all the latest blocks which is there. Okay, so there's a bit of mining going on right now, and the mining issue, and that's why there's no block has come recently. But normally it will come. So you go into any of the block, okay, it will have the transactions. Okay, so there's a new block generated out here, and this is how Bitcoin also
Yeah.
works. And there's a basically this many flow address has been transferred to this guy,
Mm.
and so I'm going to show you a blockchain address that we use and how we use it. So we have a lot of products. One of those basically we're experimenting. So it's called internship blockchain contract, and in internship blockchain contract we have this is the address, FDA, starting with FDA, and then you could see that we are transferring a minimal amount of flows.
Mm.
Okay, we are transferring a minimal amount of flow, which is the currency, which is like Bitcoin of this blockchain, and then we write some messages called flow blockchain flow data. Okay, and on the basis of this messaging, you can create applications, you can create trading systems, you can create token transfer systems, anything that any blockchain can do. You can do that by putting right amount of messages in this place called the flow data. All right? So in this case, it's a simple English language blockchain. Again, this is again one of our innovations. If you look at other blockchains, they're very complicated technical blockchains. Like Ethereum uses a language called Solidity. Okay, and that's not easy. That's not very, very easy. So I'll show you the Ethereum blockchain as well. So if you go to Ethereum blockchain explorer, called EtherScan. So EtherScan is doing the same thing that what I showed you in the flow blockchain. Okay, so it is mining the blocks and all these kind of messages, which are the blocks which are coming. So I'll click one of the blocks, and it has all these kind of transactions.
Yeah.
But if you look at those transactions, they're all technical transactions. Okay, so there's a token transfer. This transfer is a token transfer. So if you go here, and what they're doing is they're transferring. This is a very huge transfer. It's a $3 million transfer.
Mm.
The $3 million transfer, and it only took 70 cents. Okay, so the $3 million transfer which has happened from this address to this address, but if you look at the data is very, very complicated. Okay, so it's really technical. Okay, so all of this is the data out here. Okay, and you need to know, and it can also do what is called a smart contract. So this was just a simple token transfer. So let me find out if this is smart contract. These are all transfer. They're not smart contract transactions. So you have to find out a smart contract transaction. So we have to look at some other. Yeah, there's a transaction here. Let's see what that is doing. Yeah, now this is a smart contract transaction. Okay, so like approve happened. So this is one of the approved Tether as a stable coin. Also, so 95% of all transactions on all blockchains are token transfers, like a transfer of an asset that you have created. So if you go to this is the contract address, which is similar to the address that we have created. It's all binary data. Okay, and then you do kind of transactions. So this is Ethereum. So basically, the reason why we selected Flow blockchain was we could do simple English language texts. Okay, where anyone can read it. All right, and so you could see that we have some promotion, we have some messages, announcement. We take selected designs in Dribble and convert. So we figured out that if everything is English language, and then you can convert it into functional technologies. Okay, then it will be very easy to understand the blockchain, and people can coordinate, and they can also find they can do control and coordination much better if something is English other than technical knowledge. Okay, so that took us years. It was years of our work to be able to do all this, to create an infrastructure where you can build applications. And Messenger is one of those apps. So the Messenger app that I showed you, it actually takes data from the blockchain, and from that it coordinates. It knows what is the application address, what kind of data, what kind of messages. The data is coming from this flow data field out here. Okay. All right. So
one question here, like what is the algorithm used for mining? I mean, is it like proof of work or?
So Ethereum simply right now it's shifted from proof of work to proof of stake, and Flow blockchain is still on proof of work. It's a clone of Bitcoin. It does everything what Bitcoin does, except it had added this field called flow data. Okay, because we started early. So this blockchain started way before Ethereum. It started in 2014, And since we were one of the early innovators, so we realized the potential of this, and we started working on this, and so this is almost a clone of Bitcoin, and it could do except two things. It has this field called flow data, and it also uses a slightly different mining algorithm called script. Okay, Bitcoin uses SHA-256, and this also uses SHA-256 in all the transactions. But for the mining portion, it uses another algorithm called script, which is a similar hash algorithm.
Okay.
And I'm going to talk about all that. I'm going to talk about hash everything on the blockchain side, from start. So you'll understand exactly how the whole thing works. Okay. Cool. All right. So any questions till now?
No.
All right. So let's just move on to the next slide. All right. So before we go into I want to actually give you a little bit of technical background on this. But before we go into that, I want to make you as to why what is the philosophical concept of blockchain. Okay. So normally when you make a contract, you sign a piece of paper with him on stamp paper, and you sometimes you register it in the court, or you register it in any of the registration authorities, and then you don't have to show it to anyone. It's a contract between you and the other person. And then, as per Indian Contract Act or different contract regulations in the world, the courts will impose the content of this contract. All right. In Bitcoin, we don't have courts. It's a totally decentralized system. So the way Bitcoin works is that you make a deal with someone, you make a contract with someone, and you publish that contract inside the blockchain, where you have millions of witnesses. Anyone who can read the blockchain can also see the data of the contract. And because there are millions of witnesses, those are the witnesses that will execute. Some part of responsibility of the contract execution will lie on those witnesses. So witnesses will see the data in the blockchain, and they will also execute. They will do the actual transfer. Okay, and those and that enforces the contract. So, like in case of Bitcoin, you have the mining operation, and the mining operation transfers Bitcoin from person A to person B. But person A has to give a message to the blockchain as per the pre-agreed arrangement, and he has to do the contract. If he passes the messages of that contract on the blockchain, then after 10 minutes, the witnesses would simply take that contract and they will execute. So that makes blockchain very, very powerful, because it takes away execution away from your counterparty into a neutral third party. So there are many cases where you work for different companies, and you issue invoices, but you have done the work, but the payment gets delayed. And the problem is that the person who's going to give you the money is the person who is also going to lose, because he's giving you money. So because he's losing a little bit of money, so he has full interest in delaying your payments after the work has been done. Whereas in case of blockchain, this can never happen, because if you let's say promise someone that person A has to be paid some amount of money after some elapsed amount of time, then those witnesses will enforce that if the proof of work has been provided and the contract has been executed, then the money will automatically get transferred. Okay, so that's the first philosophical view as to why blockchains are so powerful. It brings trust in the system, because now you're not dependent on other party to execute it. Also, a blockchain is self-executing rule system. So we have the Constitution of India, and there we need the Supreme Court, and we need the government, and we need the police to be able to execute it. In blockchain, that does not happen. In blockchain, we simply write code, and the code tells what has to happen. And if the blockchain is powerful enough, it will execute it automatically, which also makes a very, very powerful entity. Also, a blockchain is a no broker barter system. There's no broker here. Everything is on the blockchain. And if you are, let's say, if you have an asset like a house, if you want to sell a house today, and you go to one of the sites, so you have to go one of the brokers, or you have to go one of the sites who act like a broker, and then people come and they bid for you. In case of a blockchain, you don't need the broker. The blockchain is the broker. So you're putting up an asset, and you're putting up a price. If there's a buyer at a price, the transaction will automatically happen, and asset gets transferred. And this is absolutely corruption free, and it's all absolutely delay free. And that's why these virtual assets have become so powerful these days, because they have appreciated really, really fast, because there's trust that if I have an asset and if there's a price being quoted, I will get the value as per the price. Okay. Also, Bitcoin can enforce discipline of the rules because of all the features that I just told you. So now, we can get a conceptual idea of what a blockchain is. So blockchain is a system where contracts are publicly witnessed and verified by a large number of entities. Also, one participant among the witnesses gets rewarded every fixed interval of time, and that's the genius of blockchain. So the person who so blockchain is read infinite, write one person at a time system. So every block that you see of data which is coming in blockchain is being written by one guy, and that guy gets a reward. And because he gets a reward, and he gets reward in the blockchain token itself, which has a market value, he is doing it. No one is doing it for free. Everyone is doing it for their self-interest. And that the rules are such that those self-interest enforce all the functioning of blockchain that ensure that it goes forward. Okay. And we have learned so much in economics, like the way some of the ideas that have gone into blockchain and what has happened into the crypto world, these were not even known by academicians in economics before. So all the money that you see in Bitcoin, blockchain, Ethereum, and everything has been generated inside the system. This is fresh new money. So a lot of people think that a lot of speculation which is happening and people are putting in new money, and because of the blockchain prices are high, the Bitcoin prices is high. No, it's not because of that. Bitcoin prices are high is Bitcoin is generating wealth inside the system itself. And so I really love that part of it, that you can create your own money. All right, so having given you a philosophical overview of the blockchain, I'm going to now give you a little bit of technical overview. Okay, and with this technical overview, I think I hope to keep it mild, and you will understand exactly how blockchain works. So I'm going to introduce actually five different constructs. Three of them are here. The first is called a hash function. Second, and what a hash function does, it allows us to take any random data and make it uniform, so that we can compare the lengths, we can compare, we can do things with it. So all it does, it takes any random data and it makes it uniform. Then we have something called a Merkle tree, which I'm going to explain. What a Merkle tree does is blockchain is constrained for space. So what a Merkle tree does, if you have, let's say, 1 million pieces of unique data, it first hashes each of them and then rehashes them, so that we are in such a way that we are left with exactly one hash, and that is the hash which goes into the blockchain. So it's a commitment to data, and a Merkle tree is just not a commitment to data, but it's also a compressor of data. It compresses millions of data pieces into just one hash value, which is a very important property that we need in blockchain. And now the third part, what is called a consensus. And consensus is, suppose you get a set of transactions and you hash them all, and you can Merkle tree out of those transactions. Like you compress 10,000 transactions into a single Merkle tree, into a single Merkle root. Then what consensus does is, I told you there are millions of witnesses. So all the million of witnesses, they have to agree which of the competing Merkle trees is true. We have to agree which they feel that is correct, because you can only have one transaction. If person A is sending 100 rupees to person B, then and suppose the balance is empty, then he should not be able to send another 100 rupees. So we need a consensus. We need to have a consensus mechanism by which only one person can send an amount, and once the amount has been sent, amount is totally gone from the sender part. Okay, so for that we need consensus. So let's go into details of each of them. So what hashing does, as I told you, it takes any random data and it converts that random data into a 256-bit length of hash data. Okay, and the algorithm which is used is being SHA-256. So now I have another link. And the fourth link here, hash calculator. So we'll go to the hash calculator. Right. Now you can put some data here. Okay, so I can put, let's say, my data is number 1. Just that's the data. Okay, and I'll calculate hash. So what I get is a 256-bit representation. This is in hexadecimal. Okay, in which every single number basically represents 4 bits. Okay, and they are so 2 of them is a byte. So this is a 32-byte representation, which is 256 bits. 32 into 8 is 256. Okay, now the property of hash function is that if you change even a small bit of data, okay, this whole hash will change dramatically. So you will see I'm from one, I add another one here and I calculate hash. The length is the same, but the data has changed dramatically. I'll put another number one here, and now I have totally different hash. Okay, so this is the part of the design of the hash function now. But you can put any amount of data here. Okay, so you can just go to I can collect some random data. Let's say I have this data here, which is one of the another apps that we had done, and we go and copy this, and again we generate the hash. The length is exactly the same. Now, but in this case, this data is massive. And you can basically take gigabytes of data and all of them will compress to 256 bit. So I'm just copying it, making it big. Okay, and I'll just calculate the hash. So I get this 256 hash out here. Okay, so you can also experiment. The link is with you. You can play with this and you can calculate SHA 256 hash. So this is about hash. There's nothing more than that. It takes any piece of data, it converts into a fixed length data, and then with this fixed length data, we can do things later on. Now, once you have, let's say, multiple datas, what you want is a mechanism, as I was explaining, is a mechanism to convert them into a single piece of data. So here for that, we have something called, we use that the construction I told you, it's called a Merkle tree. So let's say there are 4 pieces of data, okay? T1, T2, T3, and T4. So now we are hashing them in a certain way. And if we hash it in a certain way, we'll get exactly one hash. So here it is T1, and this is T2. And we first hash T1 to get W, then we hash T2 to get X, and then we hash W plus X and we get A. And then we stop. Then we go at this side. We take T3 and T4, we hash them, and we get Y, which is hash of T3, and then we get Z, which is hash of T4, and then we hash them again. Okay, so now we have 2 different hashes out here, and then if we again finally hash them again, we'll get a Merkle tree. Okay, so I'm going to show you this idea directly on that tool that I showed you, how the whole thing works. Okay, so that you get an idea how the whole thing works. Okay, so let's take one. Okay, we hash it out here. So we'll copy this. We'll take this hash. We'll copy this and we'll keep it. Suppose we keep it here. Okay, then we go and say 2. We hash 2. Now we get a second hash. Then we hash 3. Then we hash 4. Okay. So we now got 4 hashes. Okay, T1, T2, T3, and T4. So now what we have to do to get a tree out of it, we got to take the top 2, 1 and 2, their hashes, and we got to hash it again. So I just copy both the hashes again, but we don't want any spaces between them. Okay, we don't want any data in between them. So what we'll do is we'll remove all the spaces so that all we have is just the hashes. So we have the first hash of 1 and hash of 2 when we just place them next to each other, nothing else. Okay, and we want to make sure that there's not a single extra character here, and we then calculate the hash. If you put a single character extra, then the hash is gone. Okay, I told you, because if extra single character will change the hash totally, and you can see it out here. Right now, the hash is something like 33 and 8A. If I add 1 extra space and I calculate, the hash has totally changed. So you don't want that. You want hash to be exactly accurate. So I'll delete that extra space back again, and I'll recalculate it. So I got the 33 and 8A back. All right. So this is my hash of 1 and 2. So I'll just write here 1 and 2. And now I want to hash 3 and 4. So I'll go here. Hash 3 and 4. We'll do the same thing. We'll remove all the extra spaces because spaces are toxic here. We'll make sure there's no extra space. We calculate the hash. All right. We got this hash here. Again, we copy that. 3 and 4. Okay. And now, to get the Merkle root to just one hash, we have to hash these 2 hashes again. We'll go there back. right? So we have hash of 1, 2, and 3 and 4. So we don't want this 1 and 2 symbols here. We'll delete it. We don't want 3 and 4 symbol here. We just want the hashes. And we'll take away all the extra spaces. And now we again got one long string, which is 2 hashes placed each to each other. And we calculate a hash. And so now we got a hash starting with 8, 5, and 7, 0. So if we go there, so that's our muckle. That's our muckle root for 1, 2, 3, and 4. Okay, so that's why we created 3. So the muckle root is right. And I think we also we have an app on this also. So let me just check the RanchiMall.github.io. This is need this here. So so basically what we'll do is we'll do the same thing here. We'll separate here with a value with comma 1, 2, 3, 4, and we'll create the hash. Okay. So now we got a muckle root, and so what you get is a muckle root, and then you get some proofs out here. Okay, and proof is essentially telling you it is telling you the hash path to the root. So if anyone wants to verify, okay, whether he is part of the tree or not, so what he will do is he will take this root here, he'll copy the root, and then he will take the path here. Element is 1 here, so we'll put 1 here, and then we'll take the path of 1, and we'll do a verification here, and so it will say the so we can say that this data is actually verified. Data is verified. That means your data that you gave is part of the muckle root here, which is present in the cloud. Okay, so that's how the whole system works. So that's how muckle root works. Okay, any questions on muckle root? All right, if there's no question, then I'll go to the third part. So now we are actually ready to give you a technical definition of blockchain. If you understood muckle root, if you understood hash, if everyone understood hash, I just want to make sure that everyone did understand hash, because it's very, very important. Everyone understood what a hash function is?
Yep.
Yes?
Yes.
Yep.
Okay, everyone understood what a muckle root is?
Yes.
Yes.
Okay, perfect. So if you understand these two, now blockchain is like very easy for you, because there's nothing else to blockchain technically. So what a blockchain is? A blockchain first creates whatever transactions are. So you can have a smart contract transactions or a token transfer transactions. It has multiple transactions, which is each of them is a data, which I just showed you. So it will take some transactions. It will create a muckle root out of it through the hashing mechanism that I just told you. And now this muckle root is essentially the summary of all these transactions. Now on this muckle root, I'm going to create what is called, I'm going to do mining. And when I say mining, it means I'm going to connect it to a previous block. So I create a block out of the muckle root, and the block has as the information of the muckle root, basically it's basically muckle root information. Also, it has the raw transaction in somewhere else, but basically it's the muckle root information. And then I just look at a previous block, okay, a previous block hash. So suppose this is block number 11. I will take the hash of the whole block data. And so what we'll do is we'll put the entire block data into the hash function which I just showed you. I'll copy that into that hash box, compute the hash, and I will simply link and say the previous hash is the hash of the previous block. Okay, so my a block contains nothing but a muckle root and a previous hash. Okay, similarly, so in this case, for block number 11, the previous hash belongs to block number 10. In block number 12, the previous hash is hash of block number 11. Okay, and that's what a blockchain is. A blockchain is a linear chain. That's why it's called a chain, because it's a linear chain of blocks. Each of them contains a previous hash and the muckle. You got this idea?
Yeah.
Yes.
Okay.
Yes.
So every time so all different blockchains, what they're doing is they're figuring out how to connect to the previous block. And proof of stake does it in a different way. Proof of mining does it in a different way. But they're all trying to connect to a previous block. And the reason why it is called a chain, a blockchain, is because it's a chain of blocks. It's a linear chain of code. Every block tells the next block, and that block will tell you the further block, and that block will tell you the further another block. Okay.
Just one question over here.
Yes.
So, yes, blocks will be created in sequence. So, a 12th block will not be created unless block 11 is created.
Exactly. How can you create block 12 if you don't have the hash of block 11? Because block 12 needs to have the hash of the block 11. So block 11 must be created first. Okay.
Mm-hmm.
And once the block 11 is created, then everyone would know what the hash of that block is, because this is being witnessed by millions of witnesses. It's on the blockchain. And now if someone is going to create a 12th block, he needs to connect it with the last known hash of the block. Okay. So you have to wait till block number 11 is created. Only then block 10 will be created.
Okay. So, when I am creating the block, new block, so from where I'll get the information about what the previous block was?
You will go to the blockchain, which is an infrastructure where all so blockchain will show you the current state of all the blocks. It will tell you what is the last known block.
Okay.
Okay. And the new guy who's going to create the block, he will look at the last known block which everyone agrees to. Okay, because if everyone agrees to come in the blockchain, and then you will pick that. You only need to pick the hash. Okay, hash of the block, nothing else. You pick the hash of the blockchain and you simply add into your new block, and you put a Merkle root of all the new transactions of your block.
Okay, so let's say, I'm in the process of linking to the previous block that has been already. So you said agreed. So might be some other. So let's say Rishi, he is also trying to do the same thing. So block number 10 is already created. I am trying to create block 11, and Rishi is also trying to create a block 11.
Correct.
Okay.
Yeah. So the question is, whose block is correct? Correct. If both of you can. So basically, the system has to figure out whether Rishi or Pallav or Sanand, anyone, suppose 3 people are creating that block. Only one of your blocks is correct, and other 2 has to be rejected. Okay. So for that we have consensus. Okay. So I told you consensus. So consensus is what the consensus does. What consensus does is, suppose it has 3 competing blocks, it will pick exactly one block and say this is block number 12. Okay, so this process is done through consensus, and that consensus is proof of work in case of Bitcoin, where they do some cryptographic puzzle, and it's called proof of stake, which is kind of a voting mechanism. So basically, what happens is everyone votes on the block, and the block that gets most amount of votes, it wins. And that process is called consensus. Okay. So that was a very good question. So that's how it works. So that's how a new block comes into the picture, by consensus process. Okay. So all this proof of stake, proof of work, everything is part of the consensus system that we just talked about. Okay. All right. So again, we'll complete the picture. What is a block? Block is a commitment to a Merkle root of transactions, which is secured by consensus. Okay. So consensus is very important, because if consensus is not there, then we would not know which block number 12 is the correct block. So it's only consensus process that resolves it, and that's why we need consensus. It's a very important part of blockchain design. And then we have the definition that blockchain is a set of blocks, each linked by the hash of the previous block. Okay. Cool. So just a summary once again, quick summary. So that this is the most important slide. If you understand this, you understood blockchain. What is a blockchain? A blockchain is a linear chain of blocks, each linked through hash of the previous block. Each block contains Merkle root of hash of transactions, and every block is selected through consensus process. Everyone is clear on this?
Yeah.
All right. So this is another view. So let's suppose white is the block number 1, and then you have block number 2. At block number 2, 2 competing people came. Rishi came and Pallav came. So consensus decided that the black is not the correct block, the pink is the correct block. So this was put in the blockchain. Then block number 4, block number 5. At block number 5, again 2 people came, and so the system decided this pink is the root, and that's how the blockchain gets forward. Now, see, sometimes what can happen at some point is someone has created. So one of the rules in Bitcoin blockchain, it's only in Bitcoin blockchain, is the longest chain wins. So let's say at this point, at this pink point, someone came and created 2 black blocks. Okay. So most of the people would believe that this black block is the correct. These are the 2 correct blocks. But let's say at this point of time, another guy comes and he publishes 3 different blocks here, each linked to each other. Then we have a rule called the longest chain rule. And what the longest chain rule will do is it will discard these two blocks, it will disconnect it, and it will reconnect the blockchain with the longer chain. So at any point of time, the longest chain wins. Okay, and so the longest chain is the correct block. So Bitcoin has this thing that you should wait for at least 6 different blocks, because within 6 blocks there's a chance that someone can produce a longer block, and it has been statistically found out that if you wait 6 blocks, then your blocks are really finalized and it can never be changed. And so this is called the longest rule in blockchain. Clear?
Yeah.
All right. Okay, so now we're going to come into the applications of the blockchain. Okay, so this is just for the blockchain basics. The power of the blockchain comes as to what goes inside the transaction, just T1 and T2. Okay, and that's where the blockchain trading systems or smart contract systems or token systems, everything happens as to what is the data that you're writing in the stream. So in case of Bitcoin, the transactions carry entries of a ledger. In case of Ethereum, the transaction carries execution of a smart contract. In our case, transaction carries rules of software, but we can also do both of these. We can also do entries and we can do execution of smart contract. They cannot do. Ethereum cannot do rules of software, but we can do this in our blockchain. Okay. Transactions carrying incorporation rules of a company. So RanchiMall has been incorporated on the Flow blockchain, and so we put so our company it lives on the blockchain itself. And again, that's a concept that we invented. And so for all those rules, that also goes in the blockchain. You can also keep inventory. You can keep inventory and tracking where let's say coffee went from farmer to a supplier to distributor to all the way up to consumer. All that transactions can be kept in the blockchain. You could also suppose you design a carbon credit accounting system and trading system, you can create all those transactions can also go into the blockchain. So the fun in blockchain is when what you push in those T1, T2, T3, and T4. I will show you that again. That's very, very important. So this is the blockchain where there is T0, T1, T2, and T3. So whatever that goes into T0, T1, T2, and T3, that decides the application of the blockchain. And blockchain can basically do everything. If you could design the right way and by putting the right information in T0, T1, T2, and T3. Now,
so question.
go ahead.
So you have created one complete infrastructure for creating Merkle root and verification of the transactions, whether proof of work was there or not.
Yes.
So do every blockchain need to have complete infrastructure for all these functions?
It must have, because if any of the infrastructure is missing, it cannot operate.
Okay.
So it needs to create Merkle roots. It needs to be able to connect to the previous hash. It needs to have consensus. It needs to have validations. It needs to have block explorers. So that's why RanchiMall is taking time, right? Because there's so many missing pieces out here that you have to get all of them functional and all of them really stabilized. Okay, and even after that, things can go wrong. So one of the problem right now is the prices of the assets are extremely volatile. So one of the challenges that we are facing is how to stabilize the prices of assets so that we can give a more stable growth to our consumers. Okay, and so every blockchain system needs to have all this infrastructure. So you should not try to create it yourself. Like we had to create it ourselves because we were the first ones, and the kind of blockchain that we wanted did not exist. But when you want to start, you got to select one of the blockchain because you cannot create all this infrastructure. So you have to select one of the blockchains that can do all of these things, and then you start building applications on it. Because this is basically years of work to build all of these.
Mm-hmm.
Right. Now, once you create an application on a blockchain, okay, the foundation of that is a token system. So you have to create a token transfer system, and I want to show you a token transfer system as well. So we have another piece of software called Flow Scout, which takes data from the blockchain only. And so basically we have to create a token that represents value of a rupee. Okay, and so now here in this case, this sender flow address is sending message to this sender flow address and it's transferring 1 rupee. And this is a transaction ID. So I can take this transaction ID. So this is the detail. Okay. So if you look at so I told you the flow data. So what we have told, the flow data here is send 1 rupee hash, and then we have some additional data, okay, which is not mandatory. So in our token transfer system, you can do tokens transfers directly in English, and you can say send 1 rupee hash or transfer 1 rupee hash or rupee hash one, whatever you want to do. It's a very flexible system. And I want to show you inside the blockchain as well. So this is how it looks like. So here, this address, the sender FPF is sending 1 rupee to FBB. And after this, FBB's address, if you go and click FBB, okay, you can see that he has and if you go to his token balance, he has 5 rupees now. Okay. And he has 5 rupees because 5 different people gave him 1 rupee each, which is out here, and which is a full chain out here. Okay. And if you can't take any of those, I can copy one of these, and I can actually go to the block explorer that I just showed you, and I copy that transaction ID. And then you can see the actual message here. Okay. So here, send 1 rupee hash. Okay. So this data, so this is the T1 T0 I was talking about. So this transaction has actually transferred 1 rupee from the sender flow address to receiver flow address. Okay. So this is called a token system. So every blockchain needs a token system. And a token system is a very, very important component. And then you have to design rules in which the token gets transferred from one person to other person as per his performance in the system. All right. So the 3 elements of a blockchain system design. First, you have to do a business model design. Then you have to do a technology selection. And the most important is you have to design economic incentives for all participants. So what they will get if they perform their duties well. All right. Now, what kind of problems a blockchain can present better solution from present day world? Problems, number 1, where centralization is causing inefficiencies.
Okay. Rohit, sorry, I need to drop off for another call. But thanks for this presentation.
Sure.
Bye.
Sure. Okay. So, and problems where you want global. Okay, we already time out here. Okay, so I'll just finish in 5 more minutes. Okay, problems where you want a global collaboration without a leading nation, and problem where there's no big business or government backing an initiative. Okay, the 3 places we could have a blockchain can produce a better solution. What are the rules of a successful blockchain system? Well, the system has to be simple for people to understand, and the system must reward. It has to be simple. Okay, if it's not simple, then people won't be able to participate. And the system must reward initial participants more, yet it secures the interest of the later participants. Also, the system must not change after it has been launched. And we figured out from our experience that there must be a group of people who must benefit immediately as the user of the system. Okay? So that was all for the blockchain part. And now we have something called the carbon credit account. And I'm sure some of you already know of this. So carbon, probably I don't need to explain so much about this, but essentially a carbon, we could create the blockchain system and can fit into the carbon ecosystem. And in case of carbon credit, everything is measured in CO2e, which is called carbon dioxide equivalent. And so these are all the polluting gases of the world. And the idea in the whole system is we can calculate who is contributing to the pollution, and he should pay for the pollution to be mitigated, and it should be done through a market mechanism. That's the whole idea. So in this case, methane is CH4 and methane is 28. The CO2e value is 28, which means 1 ton of methane, 1 ton of methane is equal to 28 tons of carbon dioxide. So that's what we are accounting for. So how much of these gases are going into the atmosphere? And there are 2 kinds of emissions. Okay, emissions which are called the direct emissions, and emissions that are called the indirect emissions. And direct emissions are being used is something that your business controls, and indirect emissions are something that support your business operation but is outside your control. Okay, and you can, this presentation is with you. You can have a look at it, and essentially the 3 kind of scopes that has been defined. Which is the first scope is the direct scope, which you are responsible for. Second is your downstream scope 2, which is called the upstream scope, which is the indirect scope, and there's a third scope, it's called the indirect scope. Okay. So in short, scope 1 is burn, scope 2 is buy, and scope 3 is beyond. And these are all the ecosystem, the full ecosystem of the voluntary carbon market, like the project developer, the consultant, the third-party auditors, the credit buyers, the carbon exchanges, the carbon retailers, investors. That's the full ecosystem here. And at the core is a project developer who creates a product like a forestation project, or a project which will help reduce the emission of the carbon dioxide, or it will absorb carbon dioxide from the air. And then they create what is called as carbon credits, and which is being issued by notified agencies. There are some agencies which are issuing those carbon credits, and those carbon credits get traded, and you can trade in those markets. Okay. So the size of the voluntary carbon market is about $1 billion. Two kinds of market, which is where anyone can start this whole ecosystem. Okay. And you have to create what is called a carbon offset program. And then the compliance carbon market is about $270 billion. Okay. And there's some details which I've given here. You can have a look at it, between the voluntary carbon market and the compliance carbon market. So now the question is, what can blockchain do? Blockchain can track verifiable baselines. It can baselines means as to how do you compute. Suppose you have 1 hectare of forest. How much carbon dioxide it is reducing from the atmosphere. So that's the baseline for that. So you can verify that a person who planted 1 hectare actually only claimed carbon credits for what a 1 hectare is supposed to do and no more. So that tracking is very, very important for the system to work, and that can be done through blockchain. You can also track verifiable performance. You can also tracking verifiable account for leakage. Many times what people do is they take credits from one program and then go to the other place and take credit from other program also, okay, which is called leakage of carbon dioxide. So that is a very big problem in this market. Blockchain can reduce that also. And you also have something called a proof of additionality that you should not be doing. Suppose you are going to build a eco resort on your own, which is absorbing carbon dioxide from the atmosphere. That you would have done even without this carbon credit program. So that is not an additional infrastructure of the world that takes away carbon dioxide. Okay, so basically we should be able to actually track proof of additionality, that it's a new product and new project, and it only does when there's additional stuff out here. Not you're not repackaging old stuff as environment project. So that tracking can also happen in blockchain. And also you can definitely do double counting prevention. So there are 5 things I thought of that you could do on the blockchain, and can link all the way to the carbon credits out here. Now, this is a list of the people, the 5 different standards, 6 different standards which the world uses right now on the verifiable carbon market, in which the verified carbon standard and the gold standard are the biggest markets in the world. Okay.
So, Rohit, if I may, could I interrupt you for a second?
Yeah.
I'm so sorry, but even I need to drop off for the same call with Sanand. But Abe, thank you so much for the in-depth intro to blockchain. Just a little context on this side. Our technical expertise on this is actually quite high. Maybe not between the people on the call, me, Sanand, Pallav, and the DS guys, but we have an arm in the company, which is the carbon expert arm, right? Even us tech guys, we've integrated with various of these registries you mentioned. We sell to customers various scopes. So we have a business team which is with the carbon team capable enough of telling enterprises what their strategy to net zero be, which all reduce a lot of stuff, right? Reduction, abatement, what you can't, then you go to offset. So we have some understanding there. And by the virtue, even our team is a little exposed. There was something called Tucon.ai, which was a blockchain-based protocol, which then got rejected by Vera, VCS, if you have it somewhere here. Yeah, VCS.
Yes.
Their projects, a lot of them were Vera-based, and then they got rejected. And obviously, there is this complexity of a tree got burned. So, how much carbon dioxide did you actually offset? So there is some realization. But the team has actually no idea on how to, let's say, even if someone sends us 5-6 Bitcoin, which are getting lesser, but there are a bunch of, blockchain-based exchanges and other stuff coming around. We didn't know, how we could integrate in our own platform or something like that, So that sort of clarity or understanding wasn't there in the team. But in general, we understand the little bit crux, especially from the nature perspective, because that domain yeah, so I need to jump off. I'm so sorry, but if there's some parts of the presentation, I can look at it async, which are
the presentation has already been shared in the WhatsApp group. So I'm part of the group, and and I'm also done with it. It's like it's just done out. I'm also done.
Okay.
Got it. If you could tell us how. So we are in touch with 2 types of customers. One is your buyer, which is very specific to us, our parent org, and some of our business operations work in a way we help people who have carbon credits. We keep their inventory software, inventory management.
Yes.
And we are also talking to the other side of the customers, which is brands in London, for example, who want to say they're net zero. So they have to do a bunch of stuff before they say they're net zero. Procuring green energy, reducing, which is basically ensuring lights are switched off, then buying offsets, stuff like that. So over here, if you could sort of guide us where we could invest resources into, either looking at you guys or other blockchain providers or ourselves, just being able to think that this is something maybe where our efficiencies can be driven by some kind of blockchain or Web3 intervention. That clarity in the core team doesn't exist, is my understanding, and that's where we would really like some help with.
Yes,
Correct
sure.
me.
And that's also an evolving area. See, the thing is, blockchain as a technology itself is an evolving technology. Okay, so the reason why most of these things is not real today is because the technology was so complex till now. Okay,
Yeah.
like we could talk what blockchain could do, but it was very difficult to demonstrate it in action.
Understood. And that is why I'm thank you for the thorough intro for the whole team into the crux of the underlying system. That definitely helps.
Yes.
But
So,
yeah,
so
but
I'm also talking about the application part of it. Okay. So right now the application of blockchain into carbon credit markets, that's an open game right now because we don't have a single blockchain that unifies them all. Okay. So everyone is coming with their experimental ideas, and through a market process of selection, we will have one idea where we will have all the participants accumulating and aggregating on one platform. Okay, and that process it could take years, or it could take months, or I don't know how long it's going to take, but that has not happened yet. So the place where you could really help most people is where you have maximum economic value, right? Like with least amount of investment, your customers gets maximum economic value. Okay, and so you have to so if you have people who have you could do you have carbon. So basically you have an economic part of it where you could do carbon. You could simplify inefficiencies in carbon trading, and you could also do technical part where you could do better inventory management and better system cycle management, where everyone one place to get data, because that data itself is a very big problem in carbon market. I'm not as big expert as you guys are, but once Pallav told me, I started looking into this market. I did not find any one place where you get data easily, even the basic data. Okay, that's a huge problem, because if you don't have data, then you can't make a blockchain out of it. The blockchain has to agree on what the data is. Okay, so just creating the basic data infrastructure where everyone can join, that would be a massive up move for the whole carbon industry.
Yeah. Okay, so thank you, Rohit. So yes, I believe that this was a wonderful session where we could do hands-on on also the blockchain technology, and we'll also do some homework on our use cases and